Today's lesson is Angle Pairs, Unit 3, Day 4. Today we're going to talk about identifying different types of angle pairs and using the properties of those angle pairs to write and solve equations. In this unit, we're going to talk a lot about congruent angles. When we talk about congruent angles, they're talking about angles that have the same measure. And we use a very special symbol that has a squiggly line and an equal sign right below it. That symbol means congruent. It means those angle measures are the same. When you're looking at a diagram, the arcs at the vertexes of the angles tell you that they are congruent. So looking at that image, we can say that angle A is congruent to angle B. Vertical angles are a special type of angle pair that are created when you have two intersecting lines. Vertical angles are the opposite angles that are created by those intersecting lines, and they are always congruent. So if we look at this diagram, we can see that angle AOB is this angle right here that is 70 degrees, is congruent to angle DOC, right? And so we can use that arc and this arc to say that those two angles are congruent. Similarly, we can say that angle AOC is congruent to BOD. And then those two 110-degree angles are also congruent. What you will also see is that the 70-degree angles only have one arc, and the 110-degree angles have two arcs. Those are used to differentiate, and it pretty much tells you that 70 degrees is not the same or is not congruent to 110 degrees. Adjacent angles are angles that share a common vertex and a side. So when we're looking at this diagram, we can see that here is our common vertex, and here is our common side. And in slightly simpler terms, adjacent angles are just angles that are next to each other. Next to. So here you can also see that angle B has one arc and angle A has two arcs. So again, this tells us that angle A is not congruent to angle B, because they have a different number of arcs. Now we're going to introduce our first equation stem. We want to use this equation stem if you are given information that two angles or segments are congruent. Then you can set those numbers or expressions equal to each other. So if you know that angle AOC and BOD are vertical angles, and vertical angles are always congruent, then you can also say that AOC is 110 degrees, therefore BOD is also 110 degrees. So let's try teacher example number 1. It says to determine the value of y. Here, we are given two lines that intersect, and they intersect at this point right here, which means we are creating two pairs of vertical angles. Here we have our obtuse angles, and then we also have our acute angles. And we are given information specifically about these acute angles. We are given vertical angles 11y minus 36 on one side and 63 on the other side. Because they are vertical angles, then we can use equation stem number 1. Now we know that these are vertical angles because they are on opposite sides of each other, and they are angles created by intersecting lines. So if we use our equation stem, something is going to equal something. We know that the 11y minus 36 equals 63. And now we can solve this equation. We want to solve for y, so I want to get y all by itself. The first thing that I'm going to do is add 36 to both sides. I get 11y is equal to 99. And then I'm going to divide both sides by 11, and I get y equals 9. Okay. Try the student example number 1 on your own. Now there are 2 other relationships that we're going to talk about today. They're called supplementary and complementary angles. When you see the word supplementary, you should think about the word straight. Now straight lines have 180 degrees, and supplementary angles are when you have 2 angles who add up to 180 degrees. In other words, the 2 angles create a straight line. If we look at the angle that's 120 degrees and 160 degrees, when you add them together, you get a line that is 180 degrees. Similarly, when we talk about complementary, you should think about the word corner. Complementary angles are angles whose sum equals 90 degrees. So when you look at this 25-degree angle plus the 65-degree angle, you get a corner that is 90 degrees. And we know that it's 90 degrees because it has our little square. Using that information, we get to our second equation stem. If you're given information that the sum of 2 angles are either complementary or supplementary, you can add the numbers or expression and set them equal to 90 if they're complementary or 180 if they're supplementary. Let's see that second equation stem in question 3. Here it asks us to determine the values of x and y. And then it asks us to determine the measure of the angle that is adjacent to the angle labeled 63 degrees. In order to do this, we have to look at what information is given to us. So, a couple of things that I can see is I have vertical angles right here, and that I also have supplementary angles right here. So just so that we can demonstrate how our second equation stem works, we know that when you have a straight line, it equals 180 degrees. So I can use this plus this equals 180 degrees. Now the 2 angles that make up our 180 degree angle is 63 and 2x minus 17. Right? When I add those together, I need to start by combining my like terms. So I have to do 63 minus 17, and I get 46. So 2x plus 46 equals 180. And now I'm solving by subtracting 46 from both sides. And then I'm going to divide by 2 on both sides, and I get x equals 67. Now what's really tricky here is it's tempting to say that x is 67 degrees. However, the angle itself is 2x minus 17. It's not asking for this 67 is not saying an angle measure, it's just giving you the value of x. Later on, we need to solve for that by plugging it into 2x minus 17. But first, we know that we're able to solve for x, and we know x is 67. Now second, it asks for us to solve for y. And here we have our vertical angles. We know that they're opposite each other, so we can use our first equation stem. So we're going to do y plus 23 is equal to 63. And again, I can just solve by subtracting 23 from both sides. and I get y is equal to 40. Now, the last thing it asks us is determine the measure of the angle adjacent, and adjacent we know means next to, the angle that is labeled to be 63 degrees. So here, this is our angle that's 63, so we're really looking for this angle or this angle. And we know that they're actually the same because they're both supplementary to our 63-degree angle. There are a couple of different ways that we can figure out what that angle measure is. One is we know that 2x minus 17 is the value of that angle measure. So we can plug in our x value, 67, into 2x minus 17. 2 times 67 minus 17 is going to be 134 minus 17, which is 117 degrees. So that tells us this angle, 2x minus 17, is equal to 117 degrees. The other way that we could solve for that angle is we know that this is supplementary, right? So some value here plus 63 will equal 180. So if we subtract 63 from both sides, our question mark will be 117 degrees. One of the things that I hope becomes fun, maybe that's a bit of a stretch, is that there are multiple ways to go about solving these questions, right? So I've demonstrated a little bit of some of the ways that we can go about this question, but they're not the only ways to solve this. Try this next one on your own. And don't forget to write your reflection.